It's going to be hard to condense today's lesson, so I'm going to recommend that you watch this video and also click through all of the slides and see what's going on. Because, like, for example, on this, x of t equals cosine t, y of t equals sine t, I'm not going to go through the full explanation that I did in class, but just speed it up a little bit. So basically, yesterday, in the first lesson, we talked about parametric equations, and we have our x and our y variable that both depend on a third variable, in this case time. So when we think about this, we're seeing that both of these are what we call oscillators. From our trig unit, we remember that cosine goes up and down, up and down, up and down, and so does sine. And in fact, they both have a maximum of 1 and -1. So what's happening here in our parametric function is our x value is going back and forth between -1 and +1, and our y value is going up and down between +1 and -1. So what this ends up sketching out is actually just a circle of radius 1. This is the unit circle. And in the lesson, we actually go through plugging in some values and reviewing, like, what is cosine of pi over 6, what is sine of pi over 6, and seeing how those points we're going to trace out a circle. So then the next thing we did was consider, what if we change this up a little bit and we make x equal to cosine 2t, and we make y equal to sine of t. So what we notice about this is that our x value, cosine, has a frequency of 2 now, which means that we have 2 cycles every 2 pi, right? So frequency equals 2. So basically our x value is oscillating twice as fast as our y value. So if we think back to our unit circle when we're thinking about the outputs of these, so remember, both cosine and sine are going to cycle through all of their inputs and outputs between 0 and 2 pi, right? But if we make the frequency 2, that means we're going to have one cycle of cosine between 0 and pi, and then another cycle between 0 and pi. So remember, for cosine, a cycle is our output starts at 0, and then, it starts at 1, and then we go to 0, and then -1, and then 0, and then back to 1. That's one cycle, where cosine is positive, negative, still negative, and then it's positive again, and it's back to 1. Okay, that's cosine. And then sine, its cycle is, it starts at 0, it goes to 1, back to 0, -1, back to 0, right? 0, 1, 0, -1, back to 0, right? And sine is positive, positive, negative, negative. So what's happening here is that cosine is cycling twice as fast as sine, so x is oscillating twice as fast as y. So what happens is between 0 and pi, cosine actually goes through all of its values. It goes 1, 0, -1, 0, back to 1. So it actually goes positive to all of its positive values, all of its negative values, whereas sine only hits its positive values. So when we end up graphing this, and you can look at the lesson to see what the graph looks like, okay, what happens is our x value goes positive, negative, back to positive, but our y value only stays positive. So as we trace this point, and you'll see what happens on the graph, and you can look at the table as well. But we start at 0, or 1, 0, and what happens is our cosine wants to go negative, and then it wants to come back. So what our point does is it goes like this, shoop, shoop. Okay. Notice that our y values are only positive because right now we've only gone between 0 and pi, whereas sine is positive, and cosine's gone through all of its values. Okay. So then, after we pass pi, now we're going to start plugging in inputs bigger than pi. Well, now sine is negative, so our y value is going to be negative. And again, cosine is going to go through a full cycle where it goes through all of its negative values and all of its positive values. So what happens now is sine is negative, and cosine is going to be positive, and then negative, and then it's going to come back again, like that. Okay, so that should just be one sideways parabola. I was just showing you that it comes back. So our point goes like this. It goes boom, 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 boom. Okay, so what I did is on the animation I showed you, if we were to graph just cosine 2t by itself and sine t by itself, just on one graph, you can see that the cosine 2t shows you the x value of our parametric function, and the sine t shows us the y value. And again, so watch the animation, look at the table, look at the graph, look at the color-coded picture I have on the lesson, and hopefully that will help you understand this full example. So next we talked about what if we don't touch the frequency, but we mess with the amplitude. So we remember that cosine t sine t was just our plain old unit circle. Okay, so what happens here is we are stretching our function in the x direction by 5 and in the y direction by 3. So what happens is, instead of going, this is a radius of 1, now we're going to go to a radius of 5 in the x direction. So it gets stretched out to like here and here. And then in the y direction, we're stretching it up by 3, right? So now we go up 3, down 3. And what we end up with is this ellipse. And we say that 5 is the semi-major axis, and we say that 3 is the semi-minor axis, because it's like the radius in the vertical and horizontal direction, and the major axis is always the bigger one. So to show you another example, I'll show you what happens when y has the bigger axis. It's just going to be an ellipse stretched up. So if x is 2 cosine t, y is 3 sine t, we have our semi-major axis is 3, our semi-minor axis is 2. So now we can sketch these ellipses and define these ellipses that you worked with last year in your conics unit. And then the last thing we did was talk about another type of conic section, a hyperbola. So up until this point in the lesson, we've been working with sine and cosine a lot, but there's other trig functions we can work with. For example, we could work with like tangent t and secant t. So to figure out how this is going to look, we talked about what the outputs of tangent do. So remember that tangent kind of represents the slope of the unit circle, right? So here it is. And if we were to think about the slope, or it's the slope of the radius of the unit circle. So if we were to think about the slope, from 0 to pi over 2, the slope of this line starts as being flat, so it's 0, and it gets steeper. So it goes from 0 to infinity. So from here, tangent's going 0 to infinity, right? And then that slope all of a sudden becomes negative. So now it's going negative infinity until it hits 0 again. So now it's negative infinity to 0, because it's a negative sloping line. And then now it's still flat, but now it's going positive again. So now it's going 0 back to infinity, 0 to infinity. And then it's going negative infinity to 0 again, if you look at the slope of the radius, when you look at the unit circle. So that's what's happening with our x values in this graph. Our x values are going to go from 0 to infinity, and then it's going to come back and go negative infinity to 0, and then it's going to go 0 to infinity again, and then negative infinity back to, I don't know why I wrote infinity. I should have written 0. Okay. Now, secant's a little bit trickier to think about. If we look at our circle, we're no longer looking at slope, but rather we're looking at the ratio of hypotenuse to adjacent, because that is what secant represents. Ha, 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 ha. So if we were to draw our line like that, and we're looking at this triangle, well, the hypotenuse and the adjacent are almost the same, because the adjacent side's here, the hypotenuse is here. So when we divide them, we're going to basically get 1. So, and then if we make our angle bigger, well, now our hypotenuse is really big and our adjacent's really small. If we were to draw the triangle that goes with this, and I'm really going to try. It's hard to draw on the iPad. Okay, so the adjacent's small. So we're doing hypotenuse divided by a really small number, which is going to give us something really big, right? So what happens is we go from 1 to infinity. Okay, and basically, we use that similar reasoning to figure out what's going on with y, and we figure out that it's going from, sorry, give me a second here. Yeah, so it goes from 1 to infinity, and then, again, drawing the triangles in the second quadrant, it's going to go from negative infinity to negative 1. And then in the third quadrant, it's going negative 1 back to negative infinity. And then in the fourth quadrant, it's, again, the ratio of h over a is going infinity back to 1. So, first quadrant, x goes from 0 to infinity, y goes from 1 to infinity. What's that going to look like? Okay, so x is starting as 0, y is starting as 1, so that's up here. And then as the angle approaches pi over 2, they're both going to go to infinity, so it just looks like that. Okay. Second quadrant, x is going from negative infinity to 0, and y is going from negative infinity to negative 1. Okay, so if x is going from negative infinity to 0, that's going to be coming from this direction, and y is going from negative infinity to negative 1, so what that ends up tracing out is this. Okay? All right, next we have x going from 0 to infinity, and we have y going from negative 1 to negative infinity. So x is going 0 to infinity, y is going negative 1 to negative infinity, so that traces out this. Okay, and those should be connected in better, okay? And then last we have x going from negative infinity to 0, and y going infinity to 1. So negative infinity to 0 is going to look like this, y going from infinity to 1 is going to look like this. It traces out the rest of the hyperbola. And then if you look in the lesson, we actually show this hyperbola rotated because when we switch x and y, if we make x secant and y tangent, it makes so it's a sideways hyperbola instead of an up and down hyperbola. And again, these are functions we're going to work with more in our third block day and stuff that you've seen from Algebra 2 already. That was like a super accelerated version of this lesson and still ended up being 12 minutes, which shows you how complex the stuff is that we're doing right now. And it's important that we continue to review it and really work hard to understand it conceptually.